And 1.4.2, less essential question, how do we measure angles on a unit circle? Again, back to degrees and radians, talking about the unit circle. Just a small note here about quadrants. They work the same in the unit circle as they do on a coordinate plane. We will refer to that at different times. Positive angles always go in the positive direction first. A negative angle will start at the positive x-axis and go down. That's negative. Okay, that's positive in angle speak. Doesn't matter if it's degrees or radians, that's the same regardless. Well, number 141, get the resource page from your teacher. Hopefully you already took that home with you. Your task is to find out all of the radian measures for the angle shown on the sheet. Follow the steps below. Actually, you know what? I did not give that out yet, so that's okay. You can go ahead and copy the circle down. I have it on the next page, and I will give you an official copy on cardstock. Again, I do the cardstock thing because you're going to keep this for the whole semester, and it ends up being something we use over and over again. Basically, what we're going to do is fill this circle in. Okay, here is the unit circle. All right, and we're going to start with filling in what we know. I'm going to do degrees in blue. Okay, so here's 0 degrees. I know that one. Okay, you could also call that 360 degrees because that's the whole circle. All right, and then half the circle we should know is 180, and we start from there. Okay, if that's half of a circle, then this right here will be 1/4 of a circle, and you all know what kind of angle that is. That's a 90-degree angle. Okay, well, if that's 90 degrees and this is 180, 90 more makes 270. Okay, and then we got to look at these different places here. Now there's some angles missing here. Okay, that we don't put in here. I'm only going to do this in the first quadrant. Okay, because they're not special angles, and you should know what special angles are from geometry. Okay, special triangles are 30, 60, 90. Okay, and 45, 45, 90. That's something that you kind of got to know, and we're going to use here right now. All right, so regardless, we could see right here, this is halfway between 0 and 90. That's 45. Okay, halfway between 90 and 180. Okay, you can figure that out. Add them together, divide by 2. It's going to be 135. Halfway between 180 and 270 is going to be 225. And then halfway between 270 and 360 is going to be, let's see here, 315. Okay. And now we go back to these other angles that are still missing here. And what we're referring to there is our 30, 60, 90. We already used the 45s. Okay. So 30 or 60, process of elimination, that's 30, that's 60. The ones I left out here are 15s. They're not special triangles. Okay, but the circle still counts by 15s. Okay, these just aren't pictured. Okay, so this will be 75 here. All right, so we ignore those. Okay, we're really interested in 30, 45, 60 because they're the special triangles. Okay, so over here it'll be 15 below and 15 above 135. All right, so we'll have 120, and then we'll have 150. Okay, down here, 15 below, 15 above. I mean, that's one way to think of it. So 15 above is going to be 240. 15 below is going to be 210. Same thing here. Okay, 15 above is 330. 15 below is 300. Okay, so that's where you start all the degrees in your unit circle. So make sure you have that copied down. And then you go to radians. Okay, now we could use the degrees we just did and convert all of them to radians. That's ridiculous. Okay, let's use some logic. 0 and 2 pi is a full circle. We already said half a circle is pi. Okay, well, if this is 0 and this is pi, what's half of pi? You're right, pi over 2. Okay, so that's a half a pi, a whole pi. That's 1.5 pi's would be down here. So 3 pi over 2. 3 over 2 is 1.5. We're not going to do 1.5 pi. We're going to do 3 pi over 2. We want to keep fractions throughout the process here because we're going to have some of these that are not nice numbers like 1.5. Okay? So if we're at 0 here and we're at pi over 2 here. So what's halfway between 0 and a half? You're right, pi over 4. Okay? Well, what's 3/4 of the way? 3 pi over 4. See how that works out? Real nice. 1/4, 1/2, 3/4, 1. 1 and 1/4, okay, would be 5 pi over 4. 1 and 1/2, 1 and 3/4 would be 7 pi over 4. I know that because 7 is 3 bigger than 4, 1 and 3/4. So I have my 4th pi's all done, all my 45-degree angles. All right, now I got to go to my 30, 60 angles. And if I look at this, between 0 and pi, I have 1, 2, 3. Okay? 1, 2, 3. So if I look at my half circle broken down into thirds, what do I end up with? I end up with pi over 3, 2 pi over 3, 3 pi over 3 would be 1. Okay? Then I have 4 pi over 3, 5 pi over 3, 6 pi over 3 is 2. So I got all my 60s done. Now I go to my 30s. Okay, and I want to count how many of those that I have. All right, that's a little trickier because I have 1, 2, 3, 4, 5, 6. I'm trying to look at even pieces here. Okay. So when I look at this, here is one piece. Okay, if I keep rotating this triangle, okay, I'd have to go to here and circle that. Okay, that's 2 pieces, and then 3. All right. Okay, and okay, now I'm ready. So if I look at this, here's one piece that fits at that line, and then 2, and then 3, and then 4, and 5, and then 6. Okay, so the reason I'm showing you that is because I want you to know that this is pi over 6. This second piece would be 2 pi over 6, okay, but 2 and 6 reduces to 1/3. And then we would have 3 pi over 6, but 3 over 6 reduces to 1/2. And then we would have 4 pi over 6, but 4 over 6 reduces to 2/3. And then we'd have 5 pi over 6, which is one that I need to record because that's a new one. 5 pi over 6. Okay. And then I have 6 pi over 6, which reduces to 1. 7 pi over 6. 8 pi over 6 reduces. 9 pi over 6 reduces. 10 pi over 6 reduces. 11 pi over 6. Okay? So there's your unit circle in radians. Whoa, didn't want to do that. Okay? And really, that's the main gist of it. This problem here is looking for relationships. In other words, you got to memorize this. So anything that you can come up with that makes that easier, that's good. Okay? It should be 6, 4, 3, 2. 3, 4, 6, 1. Okay? I'm looking at denominators. Okay? If I'm memorizing it, I'm going 6, 4, 3, 2. 3, 4, 6, 1. 6, 4, 3, 2. 3, 4, 6, 2. Okay, that's how I memorize it. 1/6, 1/4, 1/3, 1/2. 2/3, 3/4, 5/6, 6/6, or 1. Okay, and so forth. Negative angles and angles bigger than 2 pi. We're going to have to come back to that, and I'll be back. Okay, problem number 143. What if you go the other direction? So at the very beginning of the lesson, we talked about how positive angles start at 0 and go in the positive direction. Obviously, negative angles go in the negative direction. So now we're going to take a look at some negative angles and how we go about determining what their positive corresponding angle would be. So letter A is negative 2 pi over 3. Now there's 2 ways to do this. You can look at your unit circle, okay, which looks like this. And you can go the negative direction, all right, starting at 0 and go negative 2 pi over 3. So I would be counting pi over 3's there. So negative 1 pi over 3, negative 2 pi over 3. all right, and get whatever that corresponding angle is. In this case, that would be positive 4 pi over 3. So negative 2 pi over 3 corresponds to positive 4 pi over 3. However, I would rather you employ a concept that you learned in Algebra 2 about reflecting. Okay, so if I know what 2 pi over 3 is, a negative, we all know from Algebra 2, reflects, so about the x-axis. So if I take this angle and I reflect it about the x-axis, where do I end up? I end up at 4 pi over 3. Negative 5 pi over 4, I would do the same thing. I would start at regular 5 pi over 4, which would be here. Okay, a negative reflects it about the x-axis, which flips you to here. So negative 5 pi over 4 is congruent to 3 pi over 4. And last, we have negative 11 pi over 6, which is right here. Negative 11 pi over 6 will be positive 11 pi over 6. If I reflect that about the x-axis, I end up at just pi over 6. What about angles that are larger than 2 pi? Okay, so 10 pi over 3 does not appear on your unit circle anywhere because it's larger than 2 pi. However, it's a circle, so it's cyclical, which means you can go around the circle as many times as you want. So if we're doing 10 pi over 3, again, there's ways that you can do this. If I count pi over 3s, I would be at 0, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5, 6, 7, 8, 9, 10 pi over 3 puts me here, which is the equivalent to 4 pi over 3. However, I think it's a little simpler to just take 10 divided by 3. And how many times does 3 go into 10? It goes in 3 times. Okay, 3 times 3 is 9. My remainder is 1. So that means I'm going 3 pi's. Okay, 1 pi, 2 pi, 3 pi's, and then 1 farther, which will be 4 pi over 3. What about 17 pi over 4? 17 over 4 goes in 4 times, so that's 16, remainder of 1. So 4 pi's, that's an even number, so you're going to end up here. I can do 1, 2, 3, 4, so here is where I am, and then 1/4 farther is pi over 4. Last, I'm combining not only a negative, but also larger than 2 pi. Doesn't matter which one you do first. I would suggest you figure out where you're at on the unit circle to start. So 25 divided by 6 is 4, with a remainder of 1/6. Okay, so 4 is an even number. It means I'm starting at 0, and 1/6 farther would be negative pi over 6. So if I go to where pi over 6 is and flip that about the x-axis, I find out that this is equivalent to 11 pi over 6. And we are going to skip the next 2 problems. We will go over those together in class.